Hey Calculus, welcome back. We have made it. We are solving elementary separable differential equations today. So this is our last main objective of Calc 1. So you have arrived, my friends. Congratulations. I've got the checklist on the screen. You all know what to do from here. All right, quick warm-up question for you. Can you match this slope field to its differential equation for me? I'll force pause on your screen. All right, so here's how I like to do it. I like to start at the origin. So here I see that has a slope of 0. So when x and y are both 0, I should get 0. So that automatically takes out a and b, because if I have 0 in the denominator, I should get either no line or a vertical line there. It's slope undefined, okay? And then what I sometimes like to do after that is just kind of generally look like in quadrant 1, I have all negative slopes. And in quadrant 1, both x and y are positive. So if I take a positive number times a positive number, I should get a positive number for my slope, so that eliminates C, so the answer must be D. All right, press pause on your screen. Can you please copy this table in your notes for me? All right, so for the types of differential equations that we study in this class, they are called separable, okay? So in other words, I can separate their variables. I can get y's on one side and x's on the other, or whatever we're using for dependent, independent variables. So we're going to practice the first step, which is just to separate the variables. So let's try this. If I have an original equation, dy dx equals negative xy squared, you always want your differential in the numerator, okay? So I can tell that my y's are going to be on the left, my x's need to be on the right, because I'm going to move this dx over to the right. I need to multiply by it, okay? So I want you to this step is not a difficult step, but you have to be really careful, because if we do the first step wrong, everything else is going to be wrong after that. So I'm going to take some time just to work on this first step of separating your variables. So looking at this, I can see my negative x is fine, because x is going to remain on the right side. My y squared needs to move over to the left, because I'm putting y's on the left, x's on the right. So how would you get rid of y squared? You divide both sides by y squared, right? So would y squared end up being in the numerator or the denominator when you move it? It would end up being in the denominator. So we're going to rewrite this as dy divided by y squared, right? Equals, now the negative x stays on the right, then I'm going to multiply both sides by dx. So you've got y's on the left, x is on the right. That would be your first step for solving a separable differential equation, okay? All right, let's try this. So what needs to move on the left? I need to move the dx, so I'll multiply both sides by dx, so x's are going to be on the right-hand side. What needs to move on this side? So I need to get rid of the y. Now the y has a +1 to it, so we're going to end up taking that entire term, okay? We're going to have to take that whole piece and move it over, okay? So will I multiply or divide by y + 1 to get rid of it? Divide, so I'm going to have dy divided by that whole term, y + 1, okay? Equals. Now be careful, is your x in the numerator or denominator? It's in the denominator, and we're leaving it on this side, so it needs to remain in the denominator. I'm multiplying by dx, so you can either write it like this, or we could have written that as like 1 over x dx, okay? This and this are the same. Either one is fine. All right, let's take a look at this third one. I'm going to move the dx over, right? The 1/5 is a constant, so you can move it or stay. I usually just keep it. And then what about the negative y? We need to move it, but look, it's attached to that 100 minus. So I'm going to take that whole thing and multiply or divide to get rid of it. Divide, so it needs to end up in the denominator on the other side. And then I'll have 1/5 times dx there. Do you see how I'm being so careful about, am I multiplying or dividing? Because I have to make sure it's in the correct location for all the next steps to work. Okay, I'm going to force pause on the screen. See if you can try the next two on your own. Hit continue when you're ready to check your answers. All right, I've got answers on the screen. Go ahead and pause if you need to make any corrections. All right, so that's going to be step 1, is to separate our variables. Step 2 is going to be to integrate. And step 3 is going to be just a whole bunch of algebra. Okay, so I want to do another warm-up. I want to practice all that algebra one more time. We've done step 1, we're going to practice step 3, and then we'll put it all together. Okay, so first pause on your screen. Go ahead and copy what I have. Okay, so we did a couple of these 2 lessons ago. When I get to this spot, okay, then as soon as I see a plus c, I need to go find that plus c by using my initial condition of 0, 3. Okay, so let's plug that in. I've got ln of the absolute value of 3 minus 1 equals 1/3 times 0 cubed plus c, right? So I've got ln of 3 minus 1 is 2, absolute value of 2 is 2. Notice when I've got a number, I can drop my absolute values, so I can just evaluate that, okay? And then this is 0 plus c. So c is ln of 2, okay? So now we are going to come back to the first place we saw that c and plug that in. So I've got ln of the absolute value of y minus 1 equals 1/3 x cubed plus ln of 2. So now I want to solve for y. I see some ln's, so always get your ln's on one side. Which side would you get your ln's on this time? We want them on the left side because I'm solving for this y, which is in this ln, so I want this ln to be positive. So I want to keep this ln on the left side. That means I'm going to move this one over, so that becomes negative ln2, and I still have equals 1/3 x cubed on the right. Okay, the point of getting your ln's on one side is to combine them. This time I can use my division rule for logs. Right, so I'm going to put that 2 in the denominator. Now I have just one log. I still have 1/3 x cubed on the right-hand side. First pause on the screen, see if you can finish it from here. See if you can solve for y. All right, so I got this far. I got y equals 1 plus or minus 2 e to the 1/3 x cubed. If you did not get that far, go ahead and pause and see where you need to make a correction. Now remember, I cannot have a plus or minus in the final answer because I'm solving for a function. I need just one output. So how do we figure it out? We'll plug in your initial condition again. So when y is 3, x is 0, 1/3 times 0 is 0, e to the 0 is 1. So do we want 1 plus, that becomes a 1. Do we want 1 plus 2 times 1 or 1 minus 2 times 1? We want 1 plus to make this a true statement. So my final answer is y equals 1 plus 2e to the 1/3 x cubed. All right, we ready for the calculus? Look at all that algebra. Lots of algebra. Just 2 steps of calculus. So here we go. All right, first pause on your screen. Can you write this differential equation as well as this initial condition? And let's just go ahead before you even copy it. Instead of y prime, let's do dy dx, because that's how I want you to write it. Anytime you see y prime, just change it to dy dx anyway. So first pause on your screen, go ahead and copy what I have. Okay, so we want to solve this differential equation. In other words, we're given a differential equation as well as one initial condition, and we want to see what function, what y, works for this differential equation and passes through that point. Okay, so let's take a look at this. So we first want to separate our variables. So I can tell I want y is on the left, x is on the right. I'm going to need to multiply by dx. And what do I need to do to the y on the right side? I need to multiply by it as well, right? So when I multiply, it should be in the numerator or denominator. It should be in the numerator. So I get y dy equals negative x dx, right? That's my first step, separate. Step 2 is integrate both sides. Now look at this. You've got this nice house, right? Integral and dy means find all antiderivatives of y. Integral and dx means find all antiderivatives of negative x, okay? So let's do that. Antiderivative of y is 1/2 y squared, technically plus c, but I'm just going to put the constant on the right side because a constant minus a constant is still a constant. The antiderivative of negative x is negative 1/2 x squared, and here's going to be my plus c, okay? That's the calculus. That's it. The rest is going to be algebra. Notice we just put a plus c, so where do we go to? We need to come back to our initial condition, right? This is the point 0, negative 2. So let's plug this in. So I've got 1/2 times negative 2 squared equals negative 1/2 times 0 squared plus c. Let's solve this for c. Negative 1/2 squared is what? Is 4 times 1/2 is positive 2. This is 0, so c equals 2. Okay, so once you've got your c, you're going to come back to the first time you put your plus c, which was right here. Okay, so I'm going to come back and rewrite this 1/2 y squared equals negative 1/2 x squared plus 2. And now we solve for y. So let's first get rid of this 1/2 by multiplying everything by 2. So that's going to give me y squared. When I multiply this by 2, I get negative x squared. When I multiply this by 2, I get 4. And then I just need to get rid of the square. So I need to square root. Don't forget your plus or minus. Okay, now I just need to pick which one, plus or minus. So come back to your initial condition of 0, negative 2. Then we go negative 2 equals plus or minus square root of negative 0 squared plus 4, right? So inside the square root, I just get 4. So I've got my equals here. So which branch makes this a true statement, the positive or the negative? The negative. So my final answer is y equals negative square root of negative x squared plus 4. So I actually had you draw this slope field for your slope field homework, question number 2, I believe, and we should have gotten something like this. Like you can see like all these kind of concentric circles. So what does this have to do with the differential equation we just solved? Well, we solved for the initial condition 0, negative 2, and I've got that point plotted as well. Now here's what we got. We got y equals negative square root of quantity negative x squared plus 4, which looks like that. And you can see this is the bottom half of a circle, right? If you were to solve this for your general form of a circle, you'd get x squared plus y squared equals square root of 4. So, equals 4. So this is a circle centered at the origin with radius 2. Now this is just the bottom half of the circle. Because if I got both pieces, like if I kept that plus or minus in it, wouldn't pass the vertical line test, right? So you'd have the top half as well, and that would be a problem for trying to find a function. So this is what, this is good because the calculus and the algebra matches the geometry. Voice pause on your screen, can you please copy example 2 for me? Okay, so we need to first separate and then integrate, and then the rest is algebra. Alrighty, so let's take a look here. I know I'm going to need y's on the left, and I'm going to bring that dx and have x's on the right. So this piece I need to move, right? Would I multiply or divide by that? I would divide, so it would end up in the numerator or denominator. It would end up in the denominator. So I have dy divided by e to the y. And then this whole piece is just going to remain as your 3x squared minus 6x. And then I'm moving the dx to the right. Okay. Now let me let's look at this, because I know step 1 is separate. Step 2 is what? Is integrate. So we need to integrate this, and I don't have an anti-quotient rule. So what would you do here? Let's rewrite this. If I have a e to the positive y in the denominator, that's the same as just having e to the negative y, right? So let's work with that. All right, so now we will need to integrate. Okay, so remember integral in dy mean find all antiderivatives of e to the negative y. So notice your inside is linear with respect to y, so antiderive the outer. Now divide by the derivative of the inner, which is just -1, equals, okay, now let's go term by term. Antiderivative of 3x squared is x cubed. Antiderivative of 6x is 3x squared. And what do I need next? I need a plus c. If you don't put your plus c, no more points for you on your FRQs. There's literally, you cannot gain any more points. You've got to remember your plus c. You're anti-deriving. Okay, so again, you really need a plus c on this side as well, but there's no need for two constants, so just put them both essentially on this side. Okay, now as soon as you put your plus c, where do you go to? Go to your initial condition and plug that in, okay? So I'm plugging in 1 for x, 0 for y. So I get negative e to the 0 equals 1 cubed minus 3 times 1 squared plus c, right? Okay, so e to the 0, notice the 0 is just touching the e. So this is 1, but I still have a negative in front. Be real careful there. This is 1 minus 3, so that's -2. Whoa. So I am getting that c is equal to -1 plus 2, which is +1. Okay, so from there, you're going to come back to the first time you put your plus c and plug that in. So I've got negative e to the negative y equals x cubed minus 3x squared, and then put your +1 in there. Okay, all right, so let's solve for y. What's the first thing I need to get rid of? First thing is the negative. So let's just multiply everything by -1. So I'll have negative x cubed plus 3x squared minus 1. Okay, what do I need to get rid of next? Next is the e, so let's take ln of both sides. Ln of this side just becomes -y. Ln of this side would not really anything I can do there. It's going to be ln of all that. And then finally, I'll get rid of the negative. So multiply both sides by -1 to get negative ln of negative x cubed plus 3x squared minus 1. Okay, notice that we did not have to use our initial condition to choose a branch this time, but it's not a bad idea to check it anyway. So when I plug in 1 inside the parentheses, I get -1 plus 3 minus 1, which becomes 1. Ln of 1 is indeed 0, so that does work for me. All right, if we want to check our work, I can come to my slope field generator here. I'm just typing in what I started with dy dx in this first line for line 2. I plugged in my point here, and then I typed in what we got for our answer, and when I highlight that, that looks really nice, right? Following those slopes very, very well. And I can give you the slope field generator if you're interested as well. All right, I'm going to force pause on your screen. Go ahead and copy mine, including the warning of be careful. Okay, so what I see a lot of is we know that the antiderivative of 1 over y is ln of the absolute value of y, right? So what I see then is, oh, well, this is that. No, it is not. That's wrong. Okay. 1 over y squared, you need to rewrite it and then just do an anti-power rule, okay? You only get ln of y as your antiderivative if you've got a linear term in the denominator, okay? So let's try these together. If I have integral of 1 over y squared, that would be y to the -2. So remember, this house means find all antiderivatives of that. So I'm going to bump the power up by 1 and then divide by this, which would just be a negative in front, and then a plus c. Okay? All right, here, if I see this, okay, this is where I would actually rewrite like that so that it's clear that my antiderivative is an ln of y. Now, please keep your absolute values on there. All right, that's going to be crucial. Here, look at your denominator. Is your denominator linear in terms of y? It is, right? There's no powers. So here is where we are going to antiderive the outer, which is going to be ln, hold the inner. Now what's the derivative of the inner? It's -1, so don't forget to divide by -1 at the end there. Just the same as multiplying by -1, okay? So that's my caution. Please be careful with that, and I will see you all in class.